Today we're going to look at exponential growth and decay. They are shown by these equations. Growth has the plus, and decay would have the minus. So, for instance, if we start with 500,000, okay, the starting amount is your A value. Okay, so this is where the A is. We want to know what our final amount is. Right? We are next going to look at we're increasing by 15%. So if I'm increasing by 15%, then I know it's growth. Okay, so what I'm going to do is I'm going to take 1 plus, but instead of a percentage, don't forget we need to turn it to a decimal. And percent means per 100 or 2 decimal places. Okay, so this is our rate, and then we'd have our time. We could simplify this to 500,000 times 1.15 t. Now, if I wanted to do this, let's see here, we'll do this 6 years later. So I'm going to let my t equal 6. So now we're going to evaluate it for an answer. So we're going to take our 500,000. We're going to take 1.15 and we're going to raise it to the 6th. Okay, so this is when we grab our calculators. So we're going to type in 1.15. We're going to use the little caret and we're going to raise it to the 6th power. Hit enter. Don't stop there, okay, because we don't want to round it. Every time you round your answer, it gets farther from the true answer. So what we're going to do now is we're going to multiply that answer times this 500,000. So times 500,000. Now we're going to hit enter. That's what our answer is. So we're going to write our answer as 1156530. Okay. And this was a problem about people. So this is 1,156,530 people. But if it's people, we're not actually going to have any decimals, right? Because we don't want to have a part of a person. Okay. So that is one of the things you need to be able to do. If you put in a decay problem, it would have just had a subtraction there. And instead of growing, we would have been decaying. So let's try it again, doing the same problem, but this time let's decay. So we're going to keep that 500,000, but we're going to do 1 minus 0.15 to the t. Okay, we can simplify that to, so 1 minus 0.15 gives us 0.85. Okay, but this time we're going to take it again to the 6 so we could see what happens when we do it with a decay. So we're going to take our 0.85, use the little caret to the 6, hit enter. Okay, you can see we're small now, right? Times, leave it in there, times that 500,000. And you get this number, which is 188,574. And I'm just going to stop there because, again, this was a people problem. Look at that huge difference. In 6 years, my 500,000 went here, or if it was a decay, 500,000 went down to 188,000. Okay, so decay brings you down, and you know that because this number is less than 1, or this number is more than 1 for growth. All right, some of the things that you need to be able to do is if you had, for instance, y equals 2 times 0.92 t. We want to know, is this a growth or decay? Since this is less than 1, we know it must be a decay. We know our initial value was 2. We can find our rate, right? Because 1 well, here, let me write it this way. 1 minus some number equals 0.92, right? So if I subtract 1 from both sides, I get 0.92 minus 1. Oops. 0.92 minus 1, sorry. That is negative 0.08, but I want the positive of that. So we can either switch it, or remember, you could divide by a negative 1 on both sides. Either way, you're going to come up with your rate was 0.08, or, move it 2 times, 8%. Okay. Let's look at another one and see if we can figure out if this is growth or decay. So f of t equals 1.2 to the t. Okay. So what is my initial value here? Yeah, that one would actually just be 1. Okay, it's understood. We don't have to write it. Now, 1.2 is more than 1, so I know it must be a growth. And I know this would be 1 plus my rate equals 1.2, right? So if I subtracted that 1, I would get my rate is 0.2. But again, don't forget, move it 2 times to find your percent, and that would give you a 20% growth. Okay. There is one other equation we're going to be talking about in this section. It is a growth, but it is dealing with compound interest. So previously we looked at P equals IRT. Okay, we're going to take it a little bit farther now. So our new equation we're going to look at is the principal, okay, the amount you start with. Actually, this was I equals PRT. Sorry. So we're going to take our principal times 1 plus the rate, very similar, except it's going to be divided by n. Okay, n is something different in the banking world. It is telling us how often it is compounded. Okay, how often does the bank figure your money? Okay, if they figure it once a year, that's annually, and that's just a 1, it disappears, it goes back to this equation. Okay, if they do it semi-annually or twice a year, then that would be a 2. So semi would be 2. Okay, if they did it quarterly, we do quarters with our grades, so that would be 4 times a year. Or maybe they do it monthly, and that would be 12 times a year. Okay, so those are some of the options. Let's see, let me see if I can find a problem that we could deal with on this one. Okay, so what if we have $500? Okay, so we're going to invest $500. That's our principal. Okay, 1 plus, it is 9%. So 9% is going to become, we move it 2 times, 0.09. Okay, so 0.09. But how often is it going to be compounded? Okay, and it's going to be compounded monthly. Well, monthly, there are 12 months in a year. Okay. And then we're just going to put T for however many years. Okay. Now, we could easily go back and figure this. So let's say T equals 3. So let me walk you through how to do this. So 500, I'm just going to leave this as 1 plus 0.09 over 12, but we're going to put in a T of 3. All right, here we go. Ready? So we're going to first start inside your parentheses, PEMDAS. So we're going to take 0.09 divided by 12, and I'm going to go ahead and hit enter. Now I'm going to add to that the 1. Okay, that's this piece. We know it's growth because of that. We're going to raise that with the caret to the 3. That gives you this number now. But now we're going to come out here and multiply it times the 500. Now it is time to go ahead and write down our answer and round. This was money because we're dealing with a bank. Money always has 2 decimal places. So there's the 2, but if I look next door, is it 5 or more? And it's not, so we're just going to leave it as $511.33. We put in $500, and in 3 years, we only made $11.33. Not the best